Good afternoon, everybody. Welcome to well, it's getting sunny now. It was raining earlier. Monday afternoon of Chem 170 with your host, me, Dr. White. Hope you had a good time since the last time we met. I got a lot done around my house and other things. I've been working on projects of mine, non-teaching projects. All right, couple of things. First of all, on a personal note, I noticed if you go to YouTube, let's do that now. You'll notice like on the 27th, there are 45 views. There's not 45 people in this class. I think it's 8. And either all of you are watching it multiple times, which is okay, or we have other people watching it, which is okay. So if you're one of those other people watching it like this one. Good afternoon, everybody. Welcome to, who's that handsome guy? But anyways, if you're not in my class and you're watching my video, leave a message in the comment area of YouTube what school you're going to or why you're watching it. Dr. White's being nosy. But anyways, that's a personal thing. Now let's get to organic chemistry. First of all, did any of you happen to drive by a gas station and think they say sell gasoline with up to 10% ethanol, and ethanol is an alcohol? Did you happen to pick up a bottle, I should bring one, of rubbing alcohol and look at the label and see it has isopropyl alcohol? That's a common name for 2-propanol, but isopropyl, and that's an alcohol? Did you happen to, and you don't have to do this, but go to either a Jewel or a liquor store, pick up a bottle of good stuff like Absolute vodka, and that contains ethanol, which is an alcohol. Did you do that? How about, were you in a big box store, maybe you have in your home, and you looked at a bottle of nail polish remover, and it contains acetone. And acetone is a ketone. Did you do that? Well, you should. Remember, organic chemistry is all around you. I stole that from SpongeBob. And it won't hurt you to think about it outside my class. All right. This Wednesday, after class, whenever we end in lab, I will be giving test number 2. I like those special effects. Yeah. Anyways, and if you go to D2L, and you all should have gotten an email with this, I have in the announcement, you got an email on Wednesday, this Wednesday, I'll give test number 2. And after our class, I'll send you the password for the PDF, test number 2 PDF file. By the way, by tomorrow afternoon or early evening, I'll have that available in the assignment area of D2L for you to download. And you'll have until Thursday, 4 p.m. And by the way, it says Wednesday, 4 p.m. If we end earlier, which we probably will, I'll send it out then. You'll still have until Thursday, 4 p.m. Take test number 2 and upload your test number 2 answers as a single PDF file. If we are face-to-face, and if you've done the practice problems, and it should take you about 40 minutes. I've seen that one in face-to-face lectures. But since we're not face-to-face, I don't have to get you over to the lab to start our lab. Take as much time as you need, but get it uploaded on time. Now, test 2 has 9 pages, 10 problems. Some of the problems are multiple part. In Chem 170, I never have and never will use multiple choice questions. Yeah, they're awful. Test 2 will cover alcohols, thiols, ethers, ethylene oxide, aldehydes, and ketones. Here's the point breakdown. Test number 2 has 11 points, general knowledge. Test number 2 has 34 points, nomenclature. There are two main nomenclature questions. One is, here's the structure, give the IUPAC name. The other is, here's the name that could include either common or IUPAC names, draw the structure. Next, you'll have 60 points. Wow, that was a change from test 1. Yes, because if you look at the videos, I've spent more time on reactions. That's where the fun is, really. And there are two types of reaction questions. The majority of those 60 points will be give the product or products to the following reaction. But there'll be, I think, 3 or 4, I forgot right now. Give the starting material or materials for the following reaction. And it adds up to 105. So that means there's 5 bonus points. As all my tests, will not be open notes or open internet or get help from a friend. I put things in my tests that unfortunately have caught people doing that. I will do what's in my syllabus. Please don't cheat. Today, after this, I'm going to do the world famous review for the next test, test 2. And Wednesday, we'll have our regular Zoom meeting with the lab and other material, and then I'll send out the password. Excuse me, I think I'm fighting a cold. Anyways, any questions about test number 2? I'm looking down at the chat to see if anybody. All right, let's go through the test 2 review. If you go, let's do that right now. You go to D2L, click on contents, click on lectures, scroll down. Now, here you got to be careful. The reason I'm showing you this is, unlike the other school, D2L doesn't let you load everything. For some, well, I'm going to say stupid reason, they only show some. And see where it says load more? Got to click on that. And now it loads more. Why they don't have it all at once? Don't ask me. Well, I think I know, because it was originally written for a very old software language and they never updated it. You will see test number 1 review as both a Word document and a PDF file. And what I'm going to be showing you, you can download from the lecture section of D2L. I almost used the wrong school computer system. And remember, when you get to the bottom, you got to click on the button load more. Why they don't have it all the way? Always don't ask me. All right. Let's do test number 2 review by me. All right. First of all, alcohols. Alcohols have this overall structure. OH group, hydroxyl, and an R group, carbons. Now, how do you name it? You name it as the longest chain with the carbon with the hydroxyl group as an alkane. You drop the E, add OL, and a number. Which carbon has the hydroxyl group? This is for acyclic. Now, that number has priority, always. And therefore, it should be the lowest number. And all the rest of the alkyl groups, you do the same. Now, if you have a ring you name the ring as a cycloalkane. Drop the E, add OL, but you don't need a number because that carbon will always be carbon number 1. Now, the following alcohol, benzene ring with an OH group on it, the common name was made the IUPAC name, phenol. Now, you should know common names. On a test, I will never ask you, what's the common name of this compound? But I will ask you, given the common name, draw the structure. And for a common name, name the R group that's attached, obviously, to the hydroxyl group. It's an alkyl group, it is. And then add the word alcohol at the end. Remember, alcohol has 70 to 90% isopropyl alcohol and the remainder water. Now, this is the only reaction I can put on more than one test, and that is, how do you make an alcohol? Well, take a double bond, add acid and water. Remember, water is HOH, you break the pi bond, and one carbon gets the H, the other gets the OH, and it follows Markov-Nikov's rule. The carbon of double bond with the most hydrogens gets the hydrogen, and the other carbon gets the hydroxyl group. Now, before I forget, so I better tell you because I could forget, your friend for test number 2 will be how many bonds to carbon? 4. Well, I gotta get this finger fixed. How many bonds to carbon? Ooh, the same thing happens on this hand. I gotta get that one fixed too. Anyway, it's getting into bad humor Monday. But your friend on test number 2 will be how many bonds to carbon? Your friend on test number 2. Do you break carbon-carbon single bonds? No, you don't. Only on combustion. That's the only reaction this semester I know of on a test where you break a carbon-carbon single bond. Very rare. Now, reactions of alcohols. If you take sulfuric acid and the little triangle means heat, you have an alcohol. Remember, another one, when you look at an organic molecule, look for what's different. That's where the fun is. That's where the action is. And what do I mean by what's different? What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, should get your attention like that. And if you have an alcohol, carbon with an OH group, adjacent carbon, hydrogen, react it with sulfuric acid, H2SO4, the little triangle, heat. You lose the H from an adjacent carbon, the hydroxyl group, meaning H2O, water, and between those two carbons, you form a double bond. Now, this follows Zasev's rule, which we went through both in lecture and practice problems, and that is you get the double bond that has the most carbons directly bonded to the carbon of the double bond. I'll say it again, but first, water break. You get the double bond. You have two choices that has the most carbon atoms directly bonded to the carbons of double bond. Next reaction. If you take an alcohol and react it with HX, where X can be chlorine, bromine, or iodine, you replace the hydroxyl group on the carbon that had the hydroxyl group with the halogen from HX. Now, a similar but not the same, because it's a different reagent, is an alcohol with SOCl2, thionyl chloride. And that replaces the hydroxyl group with a chlorine on the carbon that has the hydroxyl group. I'll never put this on a test, but if you had a double bond in R, HX could react. SOCl2, thionyl chloride, does not react carbon-carbon double or triple bonds. Now, alcohols. If you take a primary alcohol, and I'll never ask what's primary, secondary, tertiary alcohol, but I did teach you that because I use terminology in our lectures. Take a primary alcohol and bracket O bracket means oxidation reaction or oxidizing agent. If you oxidize it, you lose a hydrogen here, you form a carbon-oxygen double bond, and as you learn later on, that's called an aldehyde. If you take a secondary alcohol, 2 R groups on the carbon with hydroxyl, primary 1 R group, and you lose the hydrogen from the carbon with the hydroxyl group, and the hydrogen on the oxygen, form a carbon-oxygen double bond, and you make a ketone. Now, one thing I should mention, for this reaction, dehydration, I will never use this one as a synthesis problem. That's not fair. All right, next I talked about thiols. What do you need to know about thiols? Well, they're the sulfur analog of alcohols. Instead of an oxygen, you have a sulfur. And you should know when they stink, who do they stink? The other thing you should really know is, why does natural gas smell? Methane alone has no odor. Because of the tragedy at that Texas school back in the 1930s that killed so many teachers and students and severely injured many, many more because of a gas leak that exploded, we now put T-butyl a thiol in natural gas. And when you smell a gas leak, what you're really smelling is that thiol, and that alerts you, ooh, I better get something fixed or help and evacuate. All right, next, ethers. Ether has this structure, ROR prime. And I just asked you to know the common name for ethers. Name each R group as the alkyl group it is, and add the word ether at the end. How do you make ethers? The Williamson ether synthesis. You take an alkoxide, that's RO minus Na plus, react it with an alkyl halide, R prime X. Remember, X can be chlorine, bromine, iodine, and this oxygen attacks, did I tell you organic chemists are violent? It attacks the carbon with the halogen, kicks it out, and the oxygen bonds to that carbon. And the sodium reacts with the halogen to make the salt. Next, I talked about epoxides, really ethylene oxide. And here's the structure. You do not need to know the structure or name of ethylene oxide. By the way, ethylene oxide is a common, not IUPAC. I don't even know the IUPAC name for this. I've worked with this stuff for eons. Oh, I shouldn't have said eons, but I have. All right, or decades. Shouldn't have said that either. But anyways, 2 reactions. Take an alcohol, react it with 1 molecular mole of ethylene oxide, and you get this ether alcohol. And the R group, the carbon with the OH, is the carbon this oxygen is bonded to. If you take an alcohol and react it with more than 1 mole, N moles of ethylene oxide, or N is a whole number, 2, 3, 4, etc., you get this polyether alcohol. Now, listen closely. You have this bracket OCH2, CH2, close bracket N. N comes from the coefficient, the number of moles or molecules of ethylene oxide you react the alcohol with. Listen closely. Common mistake on test 2. I'm telling you this so you don't make it. The OH in this polyether alcohol is on the outside of the bracket. The OH is on the outside of the bracket, not inside. And now to something near and dear to my heart, aldehydes and ketones. An aldehyde, carbon double bond to oxygen, and the carbon with the double bond to oxygen has a hydrogen and an R group. We call that an aldehyde. And how do you name it? Before we go through, let's skip on right down here. Remember, you should know, and I even wrote it in my favorite color, red, which means it's important. What is a carbonyl group? You should be able to draw it and describe it with words. Here's how you can draw it. And that's a carbon atom or carbon double bond to oxygen atom or oxygen. This is a carbonyl group. And the carbon is called the carbonyl carbon. I skipped down here because now I can say, how do you name aldehydes? You find the longest chain with the carbonyl carbon, carbon double bond oxygen. Name it as an alkane. Drop the E, replace it with Al. No numbers needed because the carbonyl carbon of the aldehyde is always number 1. See, I'm an ambidextrous. I can do that with both hands. It's always number 1. Oh, in stereo. Anybody getting dizzy? Hope not. But anyways, oh, it is Bad Humor Monday. That was pretty bad. Anybody getting dizzy? But anyways, drop the E, add Al. Now, word to the wise, which I hope all my students are. When I grade a nomenclature, alcohol, OL ending, aldehyde, AL, make sure you write them, print them clearly. You don't want me guessing, is that OL or AL? Because I can be 50% wrong. I don't want to be guessing. So make sure you clearly write when you have an alcohol, the OL ending, aldehyde, AL ending. Can't have an aldehyde in a ring. Ketones. For acyclic, you find the longest chain with the carbonyl carbon. Name it as an alkane or cycloalkane. Drop the E, add ONE. Drop the E, add ONE. For acyclic, not in a ring, you need a number. That has numeric priority. It gets the lowest number. It's not going to be ever 1, because if it is, you got an aldehyde, not a ketone. But anyways, you need a number, then you do the rest of the alkyl groups like you've already done. And that number will always be the lowest. Now, for cyclic ketones, which Dr. White and Mother Nature really love, my PhD thesis was on a very specialized cyclic ketone. You need no number because the carbonyl carbon of a ring is always number 1, always. Now, there are 2 common names I asked you to know the structure of. One is formaldehyde. That's the simplest aldehyde, where R is a hydrogen. And I mentioned about that tragic situation with the Katrina trailers. I won't put that on test, but as sad because of excess formaldehyde. Dangerous chemical, but if used properly, safe. All right, next, you should know the structure name. Here's acetone. That's the simplest ketone. That's when both R and R prime are methyl. By the way, in case you didn't forget, remember acetone is the molecule 1 and 2. Later on, I'll teach you the other one. That's used for nail polish remover. Also, well, we're not doing it. acetone is used heavily in organic chemistry labs as cleaning solvent. All right, I mentioned it earlier, but I'll mention it now. You should know what is a carbonyl group. You should be able to draw a carbonyl group and describe it with what it is with words. Like I said, I think I'm fighting a cold. Oh, I should tell you, years ago, I got really sick and I went in because it was right before a test. I had to do a review. I lost my voice 5 minutes into the lecture. And I gave a 3-hour lecture, including review, without being able to talk. I wish I could forget about that night. All right, carbonyl group. Carbon, double bond to oxygen, or carbon atom, double bond to oxygen atom. And here's how you draw it. Carbon, double bond oxygen. You have 2 more bonds coming from the carbon, because there's always 4 bonds to carbon. How do you synthesize it? An aldehyde, one way, primary alcohol, oxidized aldehyde. Secondary alcohol, oxidized ketone. I just went through that. Now, a really neat way of making an aromatic ketone, where one of the R groups of the ketone is a benzene ring, is Friedel-Crafts acylation. You take benzene, this is called an acid chloride, and you react it with aluminum trichloride and the acyl group. This carbonyl, that's carbonyl 2, is bonded to the benzene ring. And you've made a carbon-carbon single bond, something very special, very rare. All right, let's talk about reactions of ketones and aldehydes. Now, the next 4 reactions, I will not put down synthesis problems for. Next 4 reactions, I'll never put down a synthesis for. Now, here we have a aldehyde or ketone, and if R prime is H, it's an aldehyde. If it's carbon, it's a ketone reacting with an alcohol, ROH, and acid catalyst. That's what H plus is. And remember, keep your eye on the carbonyl carbon. That's where the fun is. What's attached to that carbon? Our prime or H and our double prime, still there. It opens up to OH, then you get OR from the alcohol. Now, if you take 2 alcohols and, oops, I made a mistake here, or it fell off the page, and react it with an aldehyde or ketone, keep your eye on the carbonyl carbon right here. This carbon still has R prime or H, R double prime. Because you use 2 alcohols, it has 2 OR groups. Now, there's a special case which I talked about, and that is this one right here. And here, your 2 alcohols are in the same molecule. And notice you don't break carbon-carbon single bonds. Here's my R, but there's a bond between it. And I don't know why, but this bond right here, students tend to break. That's wrong. This bond right here between the 2 CH2 groups, remember the R in this right here, well, R is CH2, but don't forget that bond between those are still there. If you just put OCH2, you'd know something's wrong, because that carbon will only have 3 bonds. And remember, there's always 4 bonds to carbon. And these 2 reactions right here and here, I will never do synthesis. Now, once you get the hemi-acetal or ketal right here, acid and water, And we'll come back to this because where can you find acid and water right now where you are? In your stomach. And we'll learn later in the semester, this and the next reaction is how your stomach breaks down carbohydrates. Like if you had something good for lunch, like French fries, pizza, potato chips, all things I don't need. Anyways, you get back the aldehyde or ketone plus the alcohol you would have used to make that hemiacetal. What's attached to the carbon? How do you know some? This is one of the two cases in all organic chemistry where you have two single bonds to oxygen here and here. And you go back, lose this. What's attached to this carbon? Still attached, our prime H or H and our double prime, and that's double bond to oxygen. And from here, you get this alcohol. If you have an acetal or ketal and acid water, this is the only other case I know in all of organic chemistry where you have two single bonded oxygens to the same carbon. And here you get essentially the same products. You get back the aldehyde or ketone I would have used to make this acetal or ketal. Keep your eye on the carbon with two oxygens. What's directly bonded to it, our prime or H, our double prime is still there. You get a carbonyl. Now, technically, you get two alcohols. Technically, well, remember on my test, says give the product their products, organic. I don't ask you to balance it. So if you want to put the two there and it helps you, that's okay. If you don't, that's okay. I tell you, I'm this close to the person grading the test, me. All right, and these two reactions right here, I will never ask a synthesis problem. But now this next one, I could. And this is if you take an alkyl halide RX, where X is chlorine, bromine, or iodide, and you react it with magnesium metal, Mg. And here you make the Grignard reagent. The carbon with the halogen will be the carbon MgX is bonded to. Common mistake on test 2. Students will write the Grignard reagent like this. Everybody see this? This is wrong. It doesn't exist. This says a carbon has a halogen, the halogen has a magnesium. It's wrong. You get 0 points. Here, the Grignard, which is correct, you have a R group on a carbon. You have magnesium bonded to that, and bonded to the magnesium is the halogen. Those are different. Now, Dr. White's going to have a big smile on my face. Why? Because it's the Grignard reaction. And if you take a ketone or aldehyde, first step, react it with the Grignard reagent. Second step, acid and water. What's attached to the carbonyl carbon, R prime or hydrogen, R double prime, is still there. The Grignard attacks the carbonyl carbon, opens it up to an alcohol, and you make a carbon-carbon single bond. Something very special, something very rare. And it's so special, that's why the great French organic chemist, Dr. Victor Grignard, won the Nobel Prize for this reaction, and the one before. This reaction, I will never give a synthesis problem. That's not kosher. I don't know about kosher. That's not fair. All right, let's move on. Remember, carbonyl carbon in a ketone aldehyde is one pi bond and one sigma bond. And just like a carbon-carbon double bond, if it reacted with hydrogen and catalyst can be nickel, platinum, or palladium, you break the pi bond, and each atom, in this case, carbon oxygen, of the double bond between carbon and oxygen gets a hydrogen. You make an alcohol, because I can rewrite this like this. And if R prime was hydrogen, meaning you started with an aldehyde, you'd make a primary alcohol. If R prime is carbons, you make a secondary alcohol. Now, because this can react with carbon-carbon double bonds, Dr. H.C. Brown of Purdue, back in the late or middle 1940s, during World War II, came up with two reagents. I'm teaching you one. That's lithium aluminum hydride, LiAlH4. Think of this as a Grignard where R triple prime is H minus. And this attacks and breaks the second step acid and water. It's like a hydrogenation, this reaction. You break the pi bond, and each atom of the double bond gets a hydrogen, and you make either a primary or secondary alcohol. The advantage of lithium aluminum hydride, which I'll never put on a test, but it only attacks carbon-oxygen double bonds, not carbon-carbon double or carbon-carbon triple bonds. So it's a very, I haven't used this term before, but it's a very selective reagent. And the last reaction for test number 2 is if you take an aldehyde or ketone, but part of my gift to you is I only do this for aldehydes. And if you react it with a base, and I'll use sodium hydroxide and water, sometimes I forget to put the water in the problem set. I think I did, but in tests I usually don't. The alpha carbon connected to the carbonyl carbon has acidic hydrogens, and you can pull that off with base, NaOH. That forms an enolate anion. The enolate anion, as you see in red, attacks the other another carbonyl from the other aldehyde molecules floating around, and you do something very special, very rare. You form a carbon-carbon single bond, and it opens the carbonyl carbon of the second aldehyde to an alcohol. And this is called the aldol condensation. Now, my second gift to you in this reaction is I don't have to write two of the same aldehyde. But for you, shh, don't tell anybody I'm being nice. Shh. For you, I will on a test write it. And that's the review. Anybody have any questions about test number 2 review? Remember what I just showed you is available to you to download from D2L. When you get to the bottom, if you don't see it, got to click on the load more. Why they do that, I don't know. But you do to see it. And if you have problems, email me. Speaking about emailing me, don't forget, if you have any questions ever, remember in my class, there's no such thing as a dumb question. Some of you have sent me questions. You can do it by email. You can ask it here if you're here today. You can ask at the end of the lecture, or you can come to my office hours, Tuesday and Wednesday from 6 to 7:15. Now, if you can't make it, email me if you really need help or need to talk to me, when I'm available and you're available, I can set up a private Zoom meeting. And any questions about the review? You know something? You people look like you use me up. So I better do that. And how can I do a pick me up? Are you ready? It's time to play that fun game. Circle and name the functional group, 2 points each. Again, that fun game is circle and name the functional groups in the following 2 points each. And there you go. Your turn to have some fun. Am I nice or what? Don't answer that. And the question is, in each of the following, circle and name the functional group. 2 points each. Have fun. And remember, you're playing that fun game, circle and name the functional group, 2 points each. Are you having fun with this fun game? I hope so. Thank you, Alvaro. Nice emoji. Remember, only vote yes if you're done. If you finish early, please be patient. Try and give everyone time to finish. All right, I think everybody's done. So my turn. How do you find functional groups? You look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond. Should get your attention like that. And if we look at this molecule, ooh, an oxygen, carbon here, carbon here. This is an ether. Oh, wait, another oxygen with a hydrogen and carbon. When I'm showing the general structure, you don't have to do it, but you do have to circle and name it, and that's an alcohol. Let's go to B. Ooh, another oxygen on a carbon. And that's an alcohol. If you only circle the carbon with the hydroxyl group, that's okay. Oh, are we done? No, another oxygen. Oh, I made a mistake. I'm sorry. That should be an H. I don't know where that came from. It must be Monday. And I'll do this. I did it again. I got OH on the brain. Hold on. I think I got rid of it. And here, what is this? It's an aldehyde. And we go to C, look for, oh, another oxygen. Carbons here and here. What is that? ROR prime. And this is an ether. Oh, we're not done. Another oxygen. Here I have carbons here, here, and here. And what is this? It's a ketone. Remember, a ketone is not spelled with a Y, but if you do, I won't take off points. And if we look at D, wow, there's an oxygen here, carbon here, and here. That's an ether. Ooh, I've got a carbon here with an oxygen and a hydrogen. This, and that's an alcohol. Ooh, another oxygen, double bond to carbon, carbons here and here. right over here. And that's a ketone. Am I done? No, another oxygen. And here, carbon, double bond oxygen, hydrogens right here, carbons. What is this? An aldehyde. And that's how you play that fun game. Circle and name the functional groups, 2 points each. On a serious note, if you can't identify a functional group and name it, how do you know how to give the IUPAC name? If you can't identify a functional group and name it, how do you know what reactions it undergoes? You don't. So even though that's a fun game, circle and name the functional groups, 2 points each, it's still very serious because you should know how to do that or you're going to be lost. I don't want that to happen. Oh no, I went a whole 2 minutes to our break. God, time flies when you're having fun with reviews and aldehydes and ketones and that fun game. Let's take a 5-minute break by my, well, it went 3 minutes. Come back by my clock at 1:58, and I can get up and stretch. See you in 5. I'm back. I took an extra minute. Don't tell anybody. All right, let's go through the aldehydes and ketones problem set. All right, now the first thing, give the IUPAC name for the following. If we look at A, what's different? Carbonyl, hydrogen, carbons, aldehyde. Longest chain with the carbonyl carbon is 4. Butane, drop the E, add Al, and we're done, because the carbonyl carbon is always 1. Now, let's skip to the next page. And if we look at D, aldehyde again. Longest chain is 7. Heptane, drop the E, add Al. But, oh look, we've got not 1, but 2 of your good buddy, the methyl group. 2, we use dimethyl. Remember, the carbonyl carbon is always number 1. So that's 1, 2, 1 methyl group is on 3, the other is on 5. And you get 3,5-dimethyl-heptanal. Now, if we look at B, we have a oxygen double bond to carbon, carbons here, carbons here. It's a ketone. Find the longest chain. Excuse me, my nose was itching. I scratched it. That's why I turned off my video. Anyways, longest chain, 4 carbons, butane. For a ketone, drop the E, add ONE. Then for acyclic, which this is, not in a ring, you need to name what carbon has the carbonyl carbon. Carbon double bonds oxygen. And you give that the highest numeric priority, the lowest number. So if the end of the chain is here, 1, the carbonyl is 2, so it's 2-butanol. Now, common mistake, do not make it. In a ketone, the carbonyl carbon is never 1. Remember, you always start at the end of a chain with 1. Now, in a ketone, in a ring, you name the ring. Here we have a carbonyl, carbon here, in a ring. 6 carbons, cyclohexane. It's a ketone. Drop the E, add ONE, cyclohexanol. And the carbonyl carbon is always number 1, so you never number it, because everybody knows it's number 1. But wait, we have a methyl group and an isopropyl group. Carbonyl carbon is number 1. You go clockwise or counterclockwise to give the alkyl groups the lowest number. And this is 1, the methyl group is on 3, the isopropyl 4. Now I have 3-methyl-4-isopropyl cyclohexanone, but since I'm not holding you to the alphabet rule, for substituents, if you had put 4-isopropyl, 3-methyl cyclohexanone, I'd give you full credit. Just don't tell the IUPAC police. Now, if we have a ketone here, acyclic, you find what's the longest chain with the carbonyl carbon, that's 9. 9 is nonane. It's a ketone. Carbonyl, carbons here and here. Drop the E, add ONE. If we start from this end, the carbonyl carbon is 3. I don't have it here, but if we start the other end, 1, 2, 3, 4, 5, 6, 7. And you have to use your high-level math skills for my class, which is a little smaller number, 3 or 7. And hopefully I'll pick 3. So that's why it's 3 known and known. And if that's carbon 3, this is 4, 5, and the isopropyl group is on 6. All right, the other type of nomenclature question, draw the condensed structures for the following. How do you do this? You start from the right, move left. ALND, aldehyde, hexane, 6 carbons. Here's my 6 carbons. Remember, the carbonyl carbon is included as one of those 6. Now, as I mentioned when we first went through this, when I learned organic chemistry, my professor always wrote an oxygen, an alcohol, or carbonyl on the right. If you put the carbonyl over here, that would be correct too, but I don't do that because good habits I don't change. Next, 3-octanol. Start from the right. ONE ending, ketone. That were an E, octane. 8 carbons. Where's the carbonyl carbon? Carbon 3. Here I have 2 common names you should know, acetone, formaldehyde. And if we look at E, start from the right, move left, ONE ending, ketone. If that were an E, cyclopentane, 5-carbon ring. Here's my carbonyl, my ketone. I have, a tert-butyl group or T-butyl group on carbon 2, and here it is. All right, let's look at some reactions. Give the organic product or products for the following reaction. What do we have here that's different? An alcohol. Remember, O bracket, bracket O bracket is oxidizing reagent. I'm not asking you to learn like KMNO4, sodium dichromate, and all that. And here, primary alcohol, oxidize it, lose this hydrogen, and you get an aldehyde. Here, R is methyl. The other thing you can think of, I start with 2 carbons, I better end up with 2 carbons, because you break carbon-carbon single bonds? No, never in this class other than combustion. It's very rare, even at my level. And if you oxidize, carbon with a hydroxyl group, R here, carbons, secondary alcohol, you get a ketone. Do you break carbon-carbon single bonds? No, so I get my ring back. No, it's not a square, it's a ring. I'm an organic chemist. And the OH group is now double bonded this carbon to hydrogen. Now, in C and D, I did the chemistry instructor's favorite trick on a test. I put a big, scary R group. But if we look here, secondary alcohol, oxidize, get a ketone. Oh, by the way, if you wanted to put the carbonyl oxygen pointing on the top, that's okay too. Either way is correct. All right, let's look at E. E, we have, what's different? A benzene ring. On here, my software, I didn't catch it, has a left justified hydrogens, H3, could have been CH3. Either way is the same. But what's different? Carbonyl chloride and R group, acid chloride, aluminum chloride, and you have Friedel-Crafts acylation. What's my R group? Methyl. Here I have a T-butyl, here I have it benzene. Let's look at H. What's different in H? Oxygen double bond to carbon, hydrogen, carbon, aldehyde. Now, if R prime, instead of being a hydrogen, was carbons, it would be a ketone. Second molecule. Methyl, OH group, it's an alcohol. And I stuck it up here instead of a /H+, same thing. acid catalyst. Keep your eye on the carbonyl carbon. What's attached to that stays attached to that. The alcohol, that's our prime and our double prime, that carbon opens up to the alcohol and the RO becomes this OR. Therefore, our prime hydrogen, our double prime methyl, our ethyl, and here's the compound you get. If I do it with a ketone, same thing. Carbonyl carbon becomes this carbon. Our prime is methyl, our double prime ethyl. R from the alcohol is methyl, and you have an OH. Now, if you have two alcohols, what is this? It's carbon double bond to oxygen. It's a ketone. So here the general reaction is, if I take an aldehyde or ketone, react it with two molecules of alcohol with acid catalyst, what's attached to the carbonyl carbon stays attached. And then that carbon, this is lost, and you get two ORs. The R is from the alcohol. Now, my R prime and R double prime are my ring. Here's the carbonyl group. Becomes this carbon. We'll have two ORs, oxygen. What's my R? Isopropyl. Wow, that's a fancy looking molecule. And C, same thing, now with an aldehyde and my alcohol as the catalyst, two molecules. And it's your turn. Give the organic product or product for the following reaction. 3 points each. Remember, I'm keeping an eye on all of you. All right, I think everybody's done. Well, let's do it. All right, what's different here? Oh, an oxygen with a carbon, that's a hydrogen, carbons here, that's an aldehyde. It could have been a ketone, but it's not. All right, let's look at this, ethylene glycol. Ooh, I've got one alcohol. I've got two, an acid catalyst. Keep your eye on the carbonyl carbon. That's where all the fun is. What's attached to it, our prime or H, our double prime is still attached. And then, because you have not one, but two alcohols, you get this. So what's our prime? Hydrogen. What's our double prime? And propyl. What's our CH2? So let's build it. Here's this carbon. What's attached to it? Our prime, hydrogen. Then I have our double prime. And I have my two oxygens. And my R group is this. Do you break carbon-carbon single bonds? No. So the bond between these two CH2 groups are still there. And for some reason, students forget to put that in. If you had forgotten to put that in, your answer would sort of look like this. If you look at that carbon or this one, how many bonds? 3. No, carbon has 4. So that's why you should remember to put that bond in there, because there's always 4 bonds to carbon. Now, if we look at D, and I forgot something. And I apologize. Once in a while, even I mess up. And I'll do one, then I'll let you try one. And I'll also teach you a secret. Remember, this is going to be a secret, so don't tell anybody else. All right, if we look at this, what's the organic product or products? What's different? This carbon has 2 oxygens single bonded to it. One is an OH, one is an oxygen with carbons. On this carbon, carbons here and here. Our prime, it could have been a hydrogen, our double prime. React it with acid and water. Keep your eye on this carbon with the 2 oxygens. What's attached to that directly, carbons or hydrogens, stays attached. And you get back a carbonyl, the ketone or aldehyde you would have used to make this compound, hemi-acetal, hemi-ketal. Plus, from here, you get this alcohol. The carbon in R is the with the oxygen is the carbon in R with the hydroxyl group. So let's write this carbon first. What's attached to it? Our prime methyl, our double prime methyl. Plus, you get this alcohol. What's our ethyl? And you get this alcohol. Now, before I do one for you, let me teach you a secret. Remember, this is a secret. When I'm doing practice problems in class or a practice problem set, or the problems on a test, I say, all right, this is the reaction I want to use. So pick a number between 1 and 10 or hydrogen, and I'll put it right here. And I'll say, I'm going to pick a hydrogen. Then R prime, pick a number between 1 and 10. I'm going to pick 2. Then I'll have an OH group. Then I have an oxygen. Here I have an R group. Well, what should it be? Pick a number between 1 and 10. I'm going to be lazy. And that's how I generate all the problems. Now listen carefully. Is there another way to listen? Can you listen uncarefully? I don't know, but listen. If you make your own practice problems like I just showed you, feel free to either talk to me after class, email me and ask, are these correct? Or come to my office hours and I will be more than happy to check them for you. So you can always generate your own practice problems if you want more of them. So for this reaction, what are the two products you would get? 3 points each. Your turn. And remember, please be patient. I try and give everybody time to finish. It looks like everybody's finished. So let's take a look at this. What's different? What's not carbon, hydrogen? Ooh, 2 oxygens, single bond to the same carbon. 1 oxygen has carbons I'll call R. On this carbon, I have a hydrogen, could have been carbons, R prime. And right here, I'll call R double prime. And here's the general reaction. Keep your eye on this carbon, which is this carbon, double bond to oxygen. What's R prime? Hydrogen. What's R double prime? 2 carbons. Don't forget 4 bonds to carbon, so you can put in your hydrogens. Now the second question mark is this alcohol. What's R? CH3, and it's an alcohol, and that's how you do it. And unfortunately, I forgot to put this general reaction practice problems in the practice problem set. Bad, Dr. White. Now, if we look at E, D is the same, this different R groups. And here, if we look at here, it's pretty busy, but if you forget about circles in my writing, this the dark type material, what's different? What's not carbon, what's not oxygen, what's not carbon? My mouth got ahead of my mind, or vice versa. What's not hydrogen, what's not carbon? Get your attention, oxygen, two oxygens, the same carbon. On the oxygen, I have the same R group, OR. On that carbon, R prime is methyl. It could have been hydrogen. R double prime is ethyl. The carbon with the two oxygens becomes double bond to oxygen, ketone or aldehyde. Here, these become the alcohol. Now, if you want to put two there, you can. So here's my carbon with the two oxygens, double bond to oxygen. I have here R is methyl, R prime ethyl. And then my alcohol, which I put the quotes there. For those who want to put the two there, you can. I'm not asking you ever to balance an equation in this class, so you don't have to. But if you want to, go right ahead. And that's an ethyl group. So you get this alcohol is ethanol. Now, if you look at F, I just went real complex. And this carbon with the two oxygens is in a ring. And R prime and R double prime is the ring. Still attached to that. That becomes a carbon-oxygen double bond. The carbons on the oxygen are R, which the carbon with the oxygen here is the carbon with the hydroxide group and propyl alcohol and 1-propanol. All right, if we look at 5A, what do we have here? Ooh, a ketone. Could have been an aldehyde. H2 nickel catalyst. Catalyst I don't have written here, but can be nickel, platinum, or palladium. And you break the pi bond, and each carbon gets, each atom of the double bond gets a hydrogen. You could have written it this way. You could have written it this way. Either way works for me. And in B and C, I have the same thing. The carbonyl becomes an alcohol. Now in D, we're now reacting LiAlH4, lithium aluminum hydride. Second step, acid water. And this is a ketone. R prime is ethyl, R double prime, methyl. Ketone or an aldehyde, lithium aluminum hydride, acid catalyst. You break the pi bond of the carbonyl, and the carbon oxygen of the carbonyl get a hydrogen. You make an alcohol. And here you can write that alcohol for D this way or this way. There's actually a third way you could do it too. And in case you forgot, I have here in my home a piece of paper signed by the Board of Regents of Michigan State University that I know that. Otherwise known as my PhD degree. And in E, I just give you an aldehyde, F2. Now, oh my God, I missed another thing here. I really apologize. And let's look at this reaction. What's different? A halogen on a carbon alkyl halide. What do we have here? Magnesium. Remember, X can be chlorine, bromine, or iodine. And you form a Grignard. Remember, the magnesium is bonded to carbon with the halogen. The halogen is bonded to the magnesium. Well, what's our isopropyl? Which carbon had the halogen? This one. What's the halogen? Bromine, 4 bonds to carbon. Your turn. Give the organic product or products for the following. 3 points each. All right. Again, since I didn't put any practice problems, if you need more, think of our group from 1 to 10, or a ring, and put a halogen on one of the carbons. You can put other R groups on the ring and react it with magnesium, and you get the Grignard. What's R? What's different? Carbon with a halogen. And X can be chlorine, bromine, or iodine. In our case, it is iodine, plus magnesium metal, and you make the Grignard reagent. Excuse me. R is 4 carbons. To break carbon-carbon single bonds? No. This is the carbon with the halogen. This is the carbon that will be bonded to magnesium. On the magnesium will be the iodine. And there are 4 bonds to carbon. And again, you can make some of your own. I could do 3 carbons to the end with a chlorine, a ring with a bromine, and all those react with magnesium. If you want me to check it, send it an email or come to my office hour or ask me after class. Now, once you have the Grignard reagent, you can react it with a ketone or aldehyde. And here's, if we look at A, we have a ketone or aldehyde, in this case aldehyde, where R prime is carbon, not hydrogen. And we have one of these, doesn't matter what you call R prime, and R double prime is methyl, R prime is ethyl, R double prime methyl. What's attached to the carbonyl stays there, ethyl, methyl. It opens up to an alcohol, and that carbon, the Grignard, forms something very special, very rare, very nice and beautiful, a carbon-carbon single bond. And our triple prime is methyl. And if we look at C, same thing, carbonyl, carbon double bond to oxygen ring, it's a ketone. Ooh, R triple prime, MgX, second step acid and water. Now in here, R prime and R double prime are bonded together in the ring. So the carbon right here is this carbon in the ring. And it'll have an alcohol, OH, and our triple prime, the carbon with the Grignard, it'll be bonded to the carbon with the hydroxyl group. In this case, the center carbon isopropyl. Now, there's a mistake I just noticed in here. I'll show you in a second. Let's look at E. Yeah, and I forgot to put the water down in the problem set. Sorry. All right. But anyways, we react these two molecules. Oh, they're the same with base NaOH and water. Remember, the alpha carbon has hydrogens that are acidic. You can pull one off with a base, get an enolate anion, and that attacks the other carbonyl and forms a carbon-oxygen bond. And the other carbonyl is opened up to OH group. What's attached to that stays there. Well, in E, R is a benzene ring, because NaOH and water won't react with a benzene ring. Trust me, it won't. I'll even bet money on that. Did I tell you that if I say I bet, I already know I won? I would never say I bet unless I know how to win. I already won. And therefore, you have the first aldehyde. You remove one hydrogen. The alpha carbon bonds to the carbonyl of the second aldehyde and opens it up to an alcohol. What was attached to that carbonyl, benzene ring CH2, is still there. Now, this structure F, the bottom part where I have carbon with OH, CH2, 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 CH, CH3, guess what? I have an extra CH2. Between this carbon and this one, there should only be two CH2s. Bad, Dr. White. That was a long problem set, but I hope you find it useful when I go through these with you. Now, before we move on, let me remind all of you, there's a lab due on Wednesday. Because of some personal things in my life, I got a little behind in grading. Over the weekend, yesterday, I caught up, and I've uploaded your labs. So up to the lab that's due this Wednesday, if you hand in a lab, the grade should be in D2L, grade book. And if you did and I didn't grade it, let me know. Now, a couple of you, like I think two of you, the last lab that was due didn't hand it in. Hand it in. Even if I take off a late point or two, say 9 or 10 points is better than 0. So hand in labs. All right, any questions about aldehydes and ketones? Well, I guess not. All right, let me close some things here. All right, now last Wednesday, I had to switch off for this. I talked about lactic acid. which is the carboxylic acid also has an alcohol here, that when you work out and you feel that pain in your muscles because you worked real hard, and that's caused by your body somehow creating, which I don't know how. I'm not an, I haven't studied biology other than freshman year of high school, but it makes that, and that's what gives you that burning sensation. Now, switches off for this slide. If we look at this carboxylic acid, which is actually 3 of them, and this is not my software, but if I were to hand draw it, this is one way I could do it. It has 1, 2, 3. Remember, these are both carboxylic acids. Ways of writing a carboxylic acid. And this is citric acid, and it's the acid in lemons and limes. And give it that sour taste. If you bite into lemon, you go, ooh, is that sour? Well, that's because of citric acid. And switches off for the slide. Oh no, I just looked at the clock. And it's time for another break. Come back in about 5 minutes. I can get up and stretch, and I'll see you then. I'm back. Hopefully you are too. All right, let's continue. We're talking about carboxylic acids. Remember, carboxylic acids won't be on test 2, it'll be on test 3. Now, switches off for almost everything on this slide, but I decided to tell you carboxylic acids, and I use slang acids, really should have had carboxylic acids, have sharp and unpleasant odors. If you ever smell a bottle of vinegar, whoa, and that's only 4%. Now, oh, that reminds me of a story I can't forget. When I was managing one lab, one of the chemists dropped a bottle, about 500 ml bottle, oh, it was awful, of butyric acid, or butanoic acid. I used a common name, which I'm not teaching you. And butanoic acid, the best way to describe it, smells like vomit. Well, I had to help him clean it up. Oh, it was awful smelling. And I wound up the clothes I was wearing. Luckily at that company, I didn't have to wear a suit and tie and coat. Other companies I did. I wound up just throwing them out. By the way, you work in the chemical industry, it's always wise to keep a complete change of clothes in your car. And I always did after cleaning that up. So carboxylic acid, especially the shorter chain, have very sharp, unpleasant odor. Now, this you should know. And what is that? There's a sour taste for many of the low MW's molecular weight carboxylic acid. Vinegar has acetic acid, and that's a low molecular weight carboxylic acid. Now, I'll teach you later about polar, and this you don't have to know. They have high boiling points since they can hydrogen bond. What do you mean by that, Dr. White? Switches off for this. Remember, oxygen has a stronger electronegativity than hydrogen. Therefore, you have a very slight dipole moment here. I have another of the same molecule, same thing happens. And there's a very weak attraction, coulombic charge attraction between the hydrogen and oxygen of different carboxylic acids. And this gives them a high boiling point because you got to break that bond to go from a liquid to a gas. Now, the other thing is the hydrogen bond, and again, switches off for this, a lower molecular weight acids, carboxylic acids, make those carboxylic acids water soluble. If you think about it, vinegar is a low molecular weight carboxylic acid that's quite soluble in water. You'll learn later on, stearic acid with 18 carbons is not. All right. Now, carboxylic acids are called acids. Why? Because of the acidity of carboxylic acids. Let me just remind you, and this will never be on a test, what's an acid? A proton donor. And this is a proton. So an acid is a proton donor. Now in water, The carboxylic acid transfers a proton to water to form the hydronium ion H3O+. Switches off for this slide, but let's look at the next slide. So if you have an acid, and switches off for this, but it'll give you background for when I turn it back on. Acid, base, proton transfer, you get the conjugate base, conjugate acid. In a carboxylic acid, it transfers, this is acidic proton. This you should remember. The hydrogen on the OH of the carboxylic acid is what loses, transfers as H+, and transfers over. Notice you get, this is called the carboxylate anion. And later this chapter, I'll teach you the nomenclature of carboxylate anions. So with this in mind, I'm going to turn the switch on. Oh, anyways, first of all, turn it off. What makes the carboxylic acid acidic? Well, if we take ethanol and alcohol, see how tiny I made the arrow going to the right? If I could make it even smaller, I would. Alcohols are really not acids. This happens almost non-existent. But if I take acetic acid, it's not a strong acid, but still an acid. Again, switches off right now. And why does this happen, but this does not? Because I can draw different resonance forms, two of them. And by being able to do that, makes this more stable, makes it more likely to go there and give up a proton. You're reading the book, anybody reading the book, skip the inductive effect. All right, switch is on. Remember, acid base, you get a salt. This will never be on a test, this. Well, here, if you take a carboxylic acid, react it with a base, you'll get this carboxylate anion. Now you get water also, but on my test, I asked for the organic product or product. Therefore, you can put the water down or you don't have to. Now, after writing the slide, there's a better way for me to show this to you. And here's the better way. And what this says is, you take a carboxylic acid, and react it with a base. There are many bases, but I'm going to keep to this type of base. And from our class, where M can be sodium, sodium hydroxide, Li, lithium, lithium hydroxide, or K potassium hydroxide, and you make this carboxylate anion. And it turns out carboxylate anions are quite useful. I will teach you later in the semester when R is very long, that carboxylate anion we call soap. If you're using bar soap, not the liquid soap, that's how you make it. One way, and I'll teach you more about that. So let's take this for a spin. By the way, switch is on for that reaction that I just. And the question is, give the organic product or product for the following. If we look at this, what do we have that's different? What's not carbon? What's not hydrogen? Ooh, two oxygens, one double bonded to a carbon, and that same carbon, OH, and to that carbon, I've got carbons R. Ooh, NaOH. I can write it like this, where M can be equal to sodium, lithium, or potassium. There are other bases, but this is what we'll stick to in this class. And this is an acid, this is a base, proton transfer to form a salt, which we call a carboxylate anion. Now, one thing I should point out, I always show the charges there. One time I had, a number of years ago, I had a Chem 170 student. He said, why don't I have to show charges? I said, well, you should. And he said, well, I could prove to you don't have to. Then do I have to? I said, no, prove it to me. He said, how do you write table salt? This way or this way? I said, well, you don't show the charge there. He said, well, in that case, why do I have to show the charges there? I said, all right, you win. So you can either write it this way, which I always do, I think it looks cool, or if you write it this way, I will consider that correct. So what's our, remember what's attached to a carbon is you don't break carbon-carbon single bonds. I have 3 carbons, I end up with 3. The carbon with the double bond oxygen still bond to it, has an oxygen minus charge. What's M? Sodium. And you made this carboxylate anion. And now it's your turn. Your turn. What would be the organic product or products for a following reaction? 3 points each. right, my turn. And we look at this reaction, say what's different, what's not carbon, what's not hydrogen, get your attention quickly. Ooh, carbon, double bond to oxygen, hydroxyl group. Carbons here are, and this is a carboxylic acid. And, ooh, a base, OH at the end gives it away. And here M can be sodium, ooh, lithium, which in our case is, or potassium. And you get an acid-base reaction. Remember, this is acidic proton. What's attached to carbonyl? R, double bond to oxygen. This becomes O minus, M plus. In this case, keep your eye on this carbonyl carbon, what's attached to it? This isopropyl, carbonyl, O minus, what's M? Lithium. And I know there are 4 bonds to carbon, so I put it in. That's the carboxylate anion. You make. Now, not this molecule, but I'll teach you later when we get into fats and oils. When R is a certain length and you make this lithium carboxylate, you can go to the Home Depot or Menards and buy a spray or a gel, not a gel, stuff in a tube, not really a gel, but compound. That's called lithium grease. And it's really a lithium carboxylate anion. And I use that on the hinges and the rollers of my garage doors. I've got 2. And about 4 times a year, I lubricate them. You can buy it in a spray can or in a tube where you squeeze them out. I get the spray can, it's just easier. Now, on test 3, just like on test 2, I'll have some synthesis problems. And here's an example of one. What would I react with potassium hydroxide, KOH, to make that product? Your turn. All right, what's different here? Ooh, oxygen here, carbonyl, oxygen here, ooh, and a cation, and carbons here, a carboxylate anion. And what do you react to make a carboxylate anion? A base where M can be sodium, lithium, or in our case, potassium. And what do you start with? A carboxylic acid. In this case, what's this T-butyl group? So I'm going to have this T-butyl group. That's my R, my carbonyl. And I show charges you don't have to. I hope I got that backwards. And it's a carboxylic acid. There are 4 bonds to carbon. So if I react this with this, I will get that. All right, let's talk about a special base that I like to talk about. And that's the reaction of carboxylic acids with sodium bicarbonate. And sodium bicarbonate has this structure. Now, when you react it with a carboxylic acid, acidic proton, you get the carboxylate anion. But this one I'd like to talk about all of the products. You get water and you get carbon dioxide, and this arrow right here tells you it's given off as a gas, the CO2. Water and this carboxylate are not. Now, we're going to do the reaction, and then I'm going to tell you about the first organic chemical reaction I ever did with my hands that my father taught me when I was about 5.5, 6 years old, maybe 6.5. But before I do this, I better do this. Normally, I don't do mechanisms, but let's take a look at this. Here we have a carboxylic acid and sodium bicarbonate. For this right now, switches off, but I thought you'd be interested. It's cool. The proton will transfer to give this carboxylate anion. Now, when it transfers to the sodium bicarbonate, you get this. Now, I'm putting it in brackets because you don't really isolate it. This is called carbonic acid. It's very unstable. You notice if I lose this hydrogen and this OH group, I'll form water. And this immediately breaks down to water. And you're left with a carbon and 2 oxygens. Oh, CO2. Given off as a gas, plus you would have gotten this carboxylate anion And that's why you get 3 products here. Now, the other ones just get water, but I wanted to show this because this is important. Really? Yep, especially to Dr. White. All right, your turn to try one. Or let me try one first. If we look at the following reaction, question is, what's the organic product or products of the following? If we look here, what's different? Ooh, carbonyl, OH, and this carbons I'll call R, a carboxylic acid. And we're reacting with baking powder, NaHCO3. And all the products, you get a carboxylate anion, plus water, plus carbon dioxide given off as a gas. So if we look here, what's our 2 carbons? So I'll get this carboxylate anion, plus water, plus CO2. And I'll remind you that's given off as a gas, bubbles. That was fun. I'm gonna let you try one. Now this reaction, I'll never give a synthesis problem. That's not, that's a little. And what 3 products would you get when you do that reaction? Your turn. And please be patient. I give everybody time to finish. Everybody's finished. Yay. So what's the products? What's this? What's different? Carbonyl, oxygen on this carbon, and carbons. These are. This is a carboxylic acid. We're reacting with sodium bicarbonate baking powder. And you get 3 products, the carboxylate anion, plus water, plus carbon dioxide given off as gas. So what's my R group? Isopropyl. So I'll get this carboxylate anion, plus water, plus CO2, and the arrow up tells you it's given off as a gas. And there you go. Oh, I got to do another one, or have you do another one. And what three products do I get when I react this with this? And let's wait until everybody finishes. And everybody's finished. So let's take a look at this. What is this? Carbonyl with a hydroxyl group with carbons. Carboxylic acid. What do we have here? Baking powder. And when you react that, you get a carboxylate anion plus water plus carbon dioxide given off as a gas. Well, what's my R group? This. Therefore, I'll get this carboxylate anion plus water plus carbon dioxide given off as a gas. And that's how you do it. Now, take a look at this reaction. Can anybody see the significance of this reaction? And if you do, put it in chat or say it out loud. Everybody give up? Oh, I'll give you another 15 seconds. All right, my turn. Well, if we look at this carboxylic acid, it has the common name, acetic acid. And where do you find acetic acid? In vinegar. And here we have baking powder, sodium bicarbonate. And when you react vinegar with with baking powder, you'll get this. It's called sodium acetate plus water, but you'll see a lot of gas formed, carbon dioxide. Now, two things. One, Dr. White's going to do some artwork. Don't laugh so hard that you break a rib. I'm not responsible for that. My mother was a really good what would be amateur artists. My father was a really good amateur carver. And guess what? Not one iota of their art skills rubbed off on me, not one. But anyways, when I was about 5 or 6, the big thing in the United States was the space race with the evil Soviet Union, the communists. And they got outer space, the first man in space, but the United States got the first man on the moon. Well, when I was a boy, because of that, anything dealing with space, rocket ships, was big for little boys and older guys too, but really big. And there was this one product that you could buy, I think it was a penny. Remember, this is a long time ago. And remember, don't laugh too hard, hurt yourself. And what it was this hollow tube with a cap that had these 3 fins and it looked like a little rocket ship. And inside were these tiny little beads of the most god-awful candy you ever tasted. How do you know? Well, you gave one of these to a 5 or 6-year-old boy. First thing you do, take the cap off, dump the candy in a garbage can, and then you had a little rocket ship. And they were about this big. Well, what my father taught me, once you dump the candy, this part of the top of the rocket was an empty tube. If you inverted it upside down, it looked like a tiny little test tube. If you put in there some vinegar, then put in some baking powder, slam the cap back on, and held it like this. By one of the fins, and don't laugh too hard. It's one of my worst ones. Whatever. But if you had these chemicals in here, it start making CO2 gas. And that would build up a pressure and the cap would blast off. And it looked like you just launched a rocket. And to a 6-year-old, that was cool. By the way, my father was a great man, really cool. I liked them. My friends loved them too. But anyways, and we'd sit around with those and we could go on doing that for an hour or two. It was fun. And if your timing was good, you could hold it and the top cap would shoot off about 3 to 4, maybe even 5 feet. And for a 6-year-old, that was really cool. Now, there was one bad part to that story. At the time, and I still remember him, he moved out of state when I was about 7 or 8, and we lost contact decades ago. But my best friend at the time and his brother, my best friend was Dickie Gale. And one time, doing that with the rocket chips and the vinegar, he used up all his mother's baking powder and didn't tell her, we're out. Well, she went to bake a cake or something, and it was empty. Oh, did she get mad? And did he catch it? And I won't explain. It was not pretty. And so if you ever do that and you use up all your mother's baking powder, tell her so she can get more. Now, another thing my father loved to do, he was a great cook. My mother was a very good cook. He was a better cook, really good. And because he owned a drugstore, my father was a pharmacist. Back then, he worked Monday through Saturday all day, the whole week. When he got home, he didn't feel like cooking. But on Sunday, he didn't open up his drugstore. And when he felt like it, he'd say, this Sunday, men are cooking in the kitchen, men only. And I have two sisters. By the way, I'm in the middle. I have one sister 7 years old, older, one 7 years younger. Yes, I am in the middle. And my mother and sisters would leave the kitchen and we'd cook. And one of his favorite things, and I'm going to tell you his secret recipe or part of it, was spaghetti sauce. Now, we had a big deep chest freezer. So when we would make things, he'd make a lot, we'd freeze it. And my mother would enjoy that because for dinner, she'd pull something out in the morning, let it defrost, and cook it for our dinner. Well, the spaghetti sauce was one of his favorites. We had a stock pot, and I have one too, about 3 gallons worth. So we'd make a lot. Well, one of the things I don't know where he learned this from or he figured out himself. If you ever take your spaghetti sauce to the stuff, not in a jar, but in the really good Italian restaurants, yours doesn't taste the same. Well, there are two reasons. One, you need to add a pinch of cinnamon. In 3 gallons, you only use like almost less than a quarter teaspoon of cinnamon. I had a friend made a smaller stock pot. I taught him about that. He put a teaspoon of cinnamon in there, went over, and you couldn't even taste the tomatoes. It just tasted like a pot of cinnamon. So be careful. And high-end Italian restaurants do that. But the other thing he came up with was how to make it a little milder, nicer, richer taste. What did he do? He added sodium bicarbonate. Now, sodium bicarbonate has citric acid in the tomatoes. And if you make tomato paste, you use tomatoes, you get those stewed tomatoes, and we had a grinder to get the seeds out, plus tomato paste. And we put various seasonings in, garlic, onions, and that, salt and pepper. Now, for his trick, you cut back a little on the salt, and I'll just call the citric acid. And near the end, he'd put in 3-gallon pot, about a tablespoon or two of baking powder. And this is an acid, this is a base. You get the carboxylate anion. This won't be on a test. Plus water, plus gas, CO2, and you see a white foam on top that would dissipate. Now, carboxylate anions, smaller, like when citric acid, have a salty taste to it, like sodium chloride. So that's why he cut back on the sodium chloride. He put it in tomato paste. Now, if you know your general chemistry, acid base, this caused the pH of the tomato soup to increase. That makes it less acidic. And it gives it a milder taste, but a nicer taste. Now, a couple of years ago, I had a Chem 170 student come to me about 3 weeks after I taught this. And she said, my father and I would like to thank you for your father's tomato sauce recipe or spaghetti sauce. And I said, well, you're welcome. But she said, no, we really want to thank you. I said, well, what's up? And she said, you don't know, but my father and I suffer from acid reflux. And I worked at a company where another manager had it so bad, he needed to have an operation. That's where some of your stomach acid gets up your esophagus and burns, I've been told, and it hurts a lot. And she told me, we love spaghetti sauce on things, but because it's acidic, it burns our esophagus and that doesn't feel good. But by putting your baking powder in at the end, that makes it less acidic. And now we can enjoy things with spaghetti sauce on it. And I thanked her for sharing that story. If I look at the clock, we're just about out of time. Now, remember, when you're doing this spaghetti sauce, be very careful with the cinnamon. Just put a pinch in. Now, if you're making a big stock pot, like a couple of gallons, you go maybe a quarter teaspoon or less, stir it, taste it. And it just gives that little secret, oh, that's different than you normally have. And that's the secret a lot of restaurants use. You could also use nutmeg, but cinnamon, I think, works better. Well, since we're just about out of time, listen carefully. Don't forget, hand in your labs. Don't forget, on Wednesday, there'll be the lab we did last week. The alcohols is due this Wednesday. Also, don't forget, this Wednesday, we will at the end, I will at the end of our class and lab, which I have 4 p.m., it'll probably be earlier, I will send out an email with the password for the password protected PDF file for test 2. You'll have until the next day, Thursday, to take it, upload it as a single PDF file. Now, if you don't have a printer, like I have right over here, by the way, this is a nice HP printer scanner. Got this about 2 years ago for, I think it was $199, but whatever. And it wasn't on sale. And it's really been good. I used to have an HP 4 laser jet. This is a black white laser jet. I don't need color. But anyways, just write out the answers with the number. Don't forget to put your name on it. And with that, oh, one other thing, don't forget, if you have any questions, excuse me, I have my office hour tomorrow from 6 to 7:15, and Wednesday night from 6 to 7:15. Stop by, say hello. If you really need help, see if I can set up when we're both available with a Zoom meeting. With that, gang gesund, goodbye. I stole that from Granny and the Beverly Hillbillies. Bye.